Okay, so today our goals are to figure out what parts of series circuits or what quantities in series circuits add up, and I'll talk about what it means for things to add up in a second. But first, the first question in today's work asks you to measure the total current in a circuit, and the way that we measure current is with these ammeters. That's what measures our current in circuits, and the way that we've done this in the past is if we just put these like sort of crosshairs anywhere on the wire in the circuit, it'll give us the current running through that. So right now the current in the circuit looks like it's 0.20 amps. The way I would recommend you always measure the total of anything though is to come over to our voltage source. So I'll come over to our battery and I'll just put this right on here. So the total current in the circuit where I'm measuring it sort of right on the battery is 0.20 amps, which is what the same thing that I just read over there, but we'll see in your investigation in a second if that is always going to be the case. But to measure the totals of anything, I would usually start just with whatever our energy source is. So for total current, voltage drops, and then we'll talk about resistance a little in a second. But the next investigation asks you to use what we know about how to use voltmeters, about how to use ammeters, and sort of answer the questions of what adds up in these series circuits. So I've already got this series circuit built. I'm using a 20 volt battery and then a 30, 20, and 50 ohm resistor. They're all in series. And I'm going to measure the current through each one of these. So where it says the current, this A is for amps, this resistor A is just for A, B, and C, like how to differentiate between these three. So to measure these currents, I'm just going to take my ammeter and measure it through each one of these. So I could put this like directly on the resistor to measure the current running through there, and I would record these in my table. And then for the resistances, we're already given those. That's something that if we were doing this in lab, we would just already know based on how we could read sort of the color coding of these resistors. But again, for now, I'm going to work with these diagrams. And then for the voltage drop, you can think about this one of two ways. One, you could use Ohm's law. Wait, what was that? V equals IR. So if you want, you could calculate these voltage drops just with Ohm's law, taking our current that you measure, multiply by your resistance, and you could get that voltage drop that way. You could also use these voltmeters. So if I wanted to measure the voltage drop across this 30 ohm resistor, I'm going to put the two terminals of our voltmeter on either side of it, and I get that it's a 6 volt drop here. And so that's what I would record for my resistor A voltage drop. And then I would go through and do the same thing for each of these other resistors, 4 volts for this next one. And again, if you knew the current for those two resistors after using this ammeter, you could also just use Ohm's law. And the only difference between what I wrote here with Ohm's law than what I did before is I've added this little subscript drop because it can be used to calculate not just the voltages of like a battery, like a required voltage for a battery you're designing, but it can also tell you how much the voltage will drop through a resistor given a certain current. Now, the new thing here sort of is this total column, and this is what's going to help us answer, like, do these currents add up to some total current? Do these resistances add up to some total current? Do these voltage drops add up to some total current? So once I have these, let's say that I had 6, and in fact, let's see what this total voltage is. So I got 4 there for resistor B, and for around this 50 ohm resistor C, I got 10 volts. So these are each of my individual voltage drops. And now if I want to know the total voltage drop, just like what we did a second ago when we were trying to measure the total current, I'm going to go up here and measure the voltage drop around our battery, because that sort of tells us what the total is. It's before any of the wires have like split or before any different paths have become available, which isn't really relevant to this one, but in the future for our parallel circuits that'll be important. But our total voltage drop here is 20 volts. And so now to determine whether or not these add up, I'm thinking, okay, does 6 plus 4 plus 10 equal 20? And to me, I would say, yeah, those do add up. So it seems like voltage drops do add up to some total voltage drop. And then you would want to do the same thing with this current. So I'm not going to do this here because I think that would be taking some of the like the fun away, or any kind of intellectual stimulation away from your investigation. But if I measure this total current through the battery, 0.20 amps, I could record that in 0.20 amps. Once I record the currents through resistor A, B, and C, I could see whether or not these all actually add up to this total, or maybe they don't, and maybe I would have to come up with some explanation. But that's what I mean by these totals down here, is you can measure through the battery. Now for the resistance, though, I would want to use Ohm's law definitely for this one, because I know now what the total voltage drop is. I know now what the total current is, and it would just require me doing a solution for our total resistance. So I would plug in the things that we know. That's a decimal here, 0.20 amps times whatever our, I'll use this little subscript total to say that this is our total resistance. But then it would just require me dividing both sides by 0.20 and canceling out these 0.20s, doing 20 divided by 0.20, and I think the answer that I would get from this would be 100 ohms. And so the question then would be, do these resistances individually add up to this total resistance? And then sort of what does that mean for whether or not these resistances, voltages, currents add up? So that's the last three questions of this week's work, is like, in series circuits, do these things add up, which would mean that these individual things sum to whatever the total is in the circuit.